Hello everyone. Today we discuss about the single link list. Okay. In a link list, we have a multiple nodes are in the link list. So the in the link list we have a two section in the node. First one is a data, or another section is a reference. Reference means the hold the next address of the next node. Okay. In the data part, we can show integer, float, boolean, any type of data structure, any kind of data structure. In the reference part, we store the in the reference part we store the address of the next node. Okay, so here we draw a single link list. Okay, a single link list. There, this is the address of the every node, 2000, 3000, 4000, and last node contain the null value content in the reference part contain the null value. That means our node is end here. Okay, here in the data section we store the values. Okay, then in the link list the elements are stored in the heap section. Not like list list every element store one by one. Okay, by indexing one by one, but in link list every element are stored in a heaps in different section. Okay, we can access it by their addresses. Okay, so we done several operation in a single link list, like insert at end data, insert in the first position of the data, insert in the any position of a data. Okay, then we perform the delete tasks, like a delete in the first position, delete last, delete end, any position. Okay, in the first operation we check insert a node in the first position. Okay, if the self dot head equal to none, that means the head is empty. Then we create a new node equal to node. Then here we call the constructor of the class node. Then we pass the data. Okay, then we assign the self dot head equal to new node. Okay, that means self dot head hold a value of the new node. Okay, if the self dot head is equal to not none, then what we do? Then new dot next means reference part, where initialize equal to self dot head. That means uh, this is called a new node. Okay, and this is their next part. Okay, next part is up, you have a value sum. Then this is suppose 20. Okay, so next part we what do? Self dot head. Okay, then we reassign them self dot head equal to new node. That means self dot head that's become now 10. Self dot head that's become now 10. Okay, and it's become now 10, and next part is content at 20. Okay, that's all about. In this first insert, so let's check. This is our code of the single linked list. So here we is a class. The class name is node. Here we define a constructor. Okay, the constructor have a on constructor have a self as a pass parameter and another is the data. Okay, it is int and now variable is initialized by none. So this is a instance reference variable. Okay, it's hold the data. It is equals to data, means it is initialized by our formal argument, and another is self dot reference instance reference variable. This is initialized by none. Actually this part is hold the address of the next part. Okay, so how to insert at the first element? So insert at first. Okay, this is insert at first. So we at first here we create a node. Okay, so how do we create the node? At first we create here instance reference variable. Okay, well, we can say its object, and type of the object is node, and it's initialized by the, actually here we initialize with a constructor. Okay, node, and we pass the data, which is constructor have take on data. Okay, then that the data is created and the ref part is obviously none, reference part. Now here check if dot self dot head equal to none. Okay, then self dot head equal to new node. Okay, we already said, and here we use a counter variable for counting the how many nodes are inserted into data. Okay, if the self dot head not equals to none, that means we can say the linked list is not empty, means we have some data. Okay, then self dot head, then then new dot ref, means new dot the reference, that is obviously none, where we store the self dot head address. Okay, and in the self dot head we initialize by the new node. Okay, that means now the self dots have hold the the data of the new node, address of the new node. Okay, and we increase, then we again increment the counter, and the data is inserted successfully. Okay, let's switch check in our program how it's work. uh, okay, create a node, suppose enter the data. So because first no data enter, so this is our first element. Now we want to store at the first position. Okay, insert at first, so we choose option 1. Okay, enter the data, suppose we insert at 10. Okay, and the position is 1, obviously inserted successfully. So display at 10 is the first position. Okay, no issue. Also say here we check the how many nodes are there in the release. So we have 2 nodes. Okay, that's it. Okay, now we insert the nodes at the end of the single linked list. Okay, at the end of the single linked list. Means suppose this is a single linked list, okay, that have some data 3000, and we want to store at this particular position. Okay, means here we store a data like 40. So how we store? So if we want to store in a last position of the data, that's mean we want to travels it. Okay, travels it, travels from the last. Okay, so how it's possible? So at first we check the node is the link is empty or not. We already discussed in this part. Then we travels. Suppose example for we have a temporary value. This hold the address of the self dot head. Okay, now you run a while loop, while while loop, temp dot next not equal to none. Okay, that means this loop is run until the temp dot next, this temp dot next not equal to none. Okay, actually here we store the data, actually this position, because this position we hold a null right now. Okay. hmm. So temp equal to temp dot next. Okay, got it? Temp dot next. Then what do we do? We create a new node. Then temp dot next, temp dot next equal to new, temp dot next equal to new node. Okay, that means in a last position, like this is temp dot next. Okay, 30 n, this is temp dot next, and a new node is come here, this is called 40, this is also have a none. So temp dot next, this is a next, okay, equal to new node, is at hold the address of the new node. Okay, that's it, nothing. So if you want to check in our program, so this is our insert of the end part of the program. So here we pass the data, this is a method. Okay, in this method we at first create a node, then we check the health is none or not. If there is none, then obviously self.head equal to new node and count the increment value. If not, then we create a temporary reference variable and type is not initialized by the self.head, and then we run a loop, temp.ref, or we can write a ref or next whatever, not equals to none. Okay, then we the loop is continue until the temp.next equal to none. When the temp.next is none, actually when then the loop is terminate. Okay, terminate. So now we initialize the temp.ref equal to new node. Okay, and the self dot counter is increment, so the counter is plus plus. Okay, and the data is inserted successfully. So let's show how to insert a data in the last position. Okay, so if we want to insert a data in my program, we just create a node. Okay, enter a choice, just the first option, and we insert a 12, and now check it. 12 is stored in the last position of the data. Okay, our total node count by 3. That's it. Our next function is insert at any position. Okay, insert at any position, position, insert at any position. So in the insert at any position, okay, means suppose this is a linked list, create a linked list. 10, 20, 30, 10, 20, 30 and 40. Okay, now if we want to insert, if we want to insert in any position, that means our position is first or last, then we call the our methods like insert and first and last, that we already discussed. But if we, then we call it just in this function, insert dot add position function. Okay, but if we want to insert a node in the middle of any position, okay, then we write the program like that. Program like that. Temp, we create a reference variable, the whole address of the self dot head. Okay, then we run the loop like while temp dot next not equal to none. Okay, temp dot next not equal to none. Here we initialize another variable, just call a count local variable equal to 1. Okay, means if count equal to position minus 1, position doesn't mean position. Actually, if you want to insert a data in a particular position like 20, then we break our loop in a 10. Okay, then we insert a value in a 20. Otherwise, how? If we break our loop in 20, then the value is obviously inserted in the third position to maintain it. Then we write the position minus 1. Okay, then I terminate the loop. Okay, we terminate the loop and temp equal to temp dot next. Okay, temp equal to temp dot next. Temp equal to temp dot next. Then we new node are created. So what we now do? Temp dot next, hold the new node, okay, and new node, temp dot next. No, this is obviously not. We cut this portion. We write like new node new node dot next. New node dot next equal to temp dot next. Okay, a temp dot next equal to new node. That means intermediate nodes. Okay, this is 10 30. This is a temp, this is their next part. Okay, uh, next part. Now if we want to store 20 here, okay, what do you do? This is a new node, obviously new node. So new node dot next, this is the next part. Okay, new node dot next equal to temp dot next. Temp dot next means 30. Okay, so new node dot next equal to temp dot next, we connect it. Okay, then temp dot next means this part is temp dot next. Okay, temp dot next equal to new node. Okay, very done here. So we go in my code. Now in my code, and we check the function insert at any position. So here we pass in a method. So parameter is self. Just hold the current object, and under date and data in position. Here we create a new node. If save dot hit equal to none, then separate a new node and counter plus plus. If the position is 1, then we already sold first method would be called self insert at the first position. Okay, then we here check the temp equal to self dot head, and we get a local variable equal to count the type as int and initialized by 1. Okay, hey, here we run a loop. The temp.ref not equals to none. If the count equal to position minus 1, then break the loop. Okay, then break the loop and we take the new node dot ref equal to temp dot ref. Okay, already said temp dot ref equal to new node. Okay, data insert successfully, and we increment the counter. Okay, so we check it. Suppose we have a value 10, 11, 12. Okay, now we insert a 13. Now we insert any value in a position in the position 2. Insert at any position. Data like 90. Enter data in the position 2. Okay, then check it. 90 is stored in a position 2. Okay, now if we want a delete section, okay, delete operation. If we want to delete at the first position, if the link list is empty, then we obviously print a message a link list is empty. It can't be deleted anywhere because no data is present. Now if we want to delete, if the link list is full, okay, if the link list is full, then we what to do? Restrict. If the link list is full like that, then what to do? Suppose we delete a first element like this in the data, then we simply just write it self dot head equal to self dot head dot next. Okay, that means now the head is point to the this address. Okay, AGAD, head pointer. This is our head pointer. Okay, stored a 1000. This is also a 1000. So self dot head dot next means the next address of the head pointer. Next address is become like this is two, 2000. Okay, so now the head is point to the this particular position. Okay, so we achieve this, write this. Where is? Okay, so we are go to our code part. So here we come a code part and we check to how to delete a first position. So just at first we check the self dot head equal to none or none. If the equals to none, then print a empty list. If it is not empty, then we go to the else part. Then we simply just write self dot head equal to self dot head dot ref, and the is addressed to the next node of the head. Okay, and obviously we decrement the counter self dot counter equal to -1. Okay, so one value is one node is left. So let's run the program. Okay, delete at first position 5. Okay, now check 5 is gone. Sorry, means 10 is gone. Now we have a 3 node 90, 11 and 12. Other we have a in the previous we have a 4 node 10. 10 is gone. Okay, so de delete at last. Delete at last means we want to delete this node. Okay, so if we want, if the any one node is present in the this linked list, suppose, then we call the our old methods that where the position equal to 1, then we this method work. But if we want to delete at the last, then we go the travels of from the first to last. Okay, but how it's work? Okay, then we at first create a temp value, temp equal to self dot head, temp equal to self dot head. Okay, while part temp dot next not equal to none, temp dot next not equals to none. Okay, here what I say, check if count equal to position -1. Okay, position -1. You want to delete at the, just a minute. Yes, oh, here not use the position part. Actually you just only run the loop. Okay, so temp dot next. Okay, here work like a temp dot next, just like that. Temp dot next. Sorry for my mistake. And equal to none. Okay, then temp equal to temp dot next. Temp equal to temp dot next. Okay, next. Then we assign that only temp dot next equal to none. That's it. What do we do? Here we just, this is temp. Okay, this is temp dot next, and this is temp dot next dot next. So equal to none. This is temp. We go to the another round, then temp is go there. That means now the temp is this temp, now the temp is this temp. Okay, then again terminate, then temp dot next is this. Okay, then this is a temp dot next. Okay, this is obviously none. So we, in the temp dot next, in this position, we assign by the none value. So cut it this, and this is none, so we can't access this value. Okay, so we go to our code and we check. So delete at the last position. So we check the separation and we obviously print a empty single linked list. Then if the only one node is present, then we check the counter equal to 2, and then set the delete at first position. This function is method is called. Now it's come to the this part. Okay, temp equal to self dot head. Okay, initialize it. While part temp dot ref not equals to none, already said. It's check the next node is present or not. If the next node after the first iteration, if the present not present, then the loop is terminate. Otherwise, loop is run. Suppose is not present. Okay. Then we come out the loop, and the previous node, of the this node, if we want to delete, then we just we initialize the in the reference part, or the temp dot reference part of the second last node equal to none. Okay, then we decrement our counter and delete successfully. So how this work? Just check it. Suppose we 12 delete at last. So 12 is gone. Now we want to delete at any position. So how we go to any position? So we'll discuss this part. Now if we want to delete at any position, so if position equal to 1, then we of course call the method is called delete from the first position. If the position equal to count, then we call the method the delete from the last position. We already done this method. now we call the intermediate methods. There are intermediate nodes that want to be deleted. Then we go to the temp.self.head. That's mean we store the reference of the self.head in a reference variable temp. Okay, that's it. Then we then we create a local variable is a count equal to 1, and while part where we check the temp dot ref not equal to none. Okay, now check if the count equal to position minus 1 then break, because we want to cut out one node before. Okay, then temp equal to temp dot next. Okay, next temp equal to temp dot next. That's it. Now we create a third variable that's called tempo equal to temp dot ref. Store the variable of the temp dot ref references, and temp dot ref equal to temp dot ref. That means temp dot ref equal to now address to the next node. Okay, and a temp equal to initialize with none. Okay, and we decrement the value self dot counter equal to 0. No, sorry, counter equal to -1. Okay, that's all. Here we create, suppose this is nodes, one the node, this is another node. Now this is 10, this is 20, this is 30. So we cut out this node from this and we connect it to this. Okay, and temp equal to none. That means we delete this node. Okay, that's it. So we go to our in the code section at first. Okay, this is our code section. I say if the position equal to 1, then the delete at first is called. If the else position equal to self dot counter, when the node and the position are same, then we delete the last value. The call is to delete at last position, and we come to the else part. Here we temp equal to self dot head. Okay, and count equal to 1. Okay, and while part is go while part is travels where the temp dot ref not equal to none. Here we check the count equal to position -1. Means we terminate the loop before the position is come. Okay, because we want the delete a particular node, then temp equal to temp dot ref. Okay, and that's the help of this we incrementing or traversing. Then we initialize the tempo, another instance of a variable equal to temp dot ref. Then the temp.ref is initialized by the temp equal to ref.ref. Okay. When next node, and the temp equals to none. Now the middle node is invalid, and decrease the self.counter equal to -1. That's all, and print it. Just check. Delete at any position. Suppose enter the position, last position, 2. Jitter successfully. Now display it. Okay, 11 is gone. That's all about my code.